This next situation asks, in which scenario would a 6 kilogram mass generate the most stretch? And says that all springs are identical. So in this problem, we have three options. One spring, two springs connected end to end, which is in series, or two springs attached to a piece of the mass in parallel. Now there's a rule for Hooke's law, and we talked about this in class, that it's easier to stretch something when they're connected end to end than it is when they're in parallel. And that has to do with the summation of the forces. So the equations for each are as follows. When you are in series, you need to have an overall lower coefficient, which means it's easier to stretch. So that means equation-wise, we would end up with total K, which is spring constant, equals the inverse of 1 over K1 plus 1 over K2. So in this situation, if the K's are equal, that means we end up with half the K. So two springs connected end to end is a spring constant of half a K. Two springs connected next to each other in parallel, you just sum up the K's. So that would be K1 plus K2. So that would be double the K. And then 1 by itself is just going to be a single K. So if we look at the ideas between these three, which one is going to be able to stretch an object the most? It's going to be the one with the smallest spring constant, which is going to be K over 2. This is always the case. Two springs connected in series are always going to stretch more than springs connected either in parallel or solitary springs by themselves. And this all has to do with the relationship of the K's. So in series, 1 over K1 plus 1 over K2 inverted is your new K. In parallel, K plus K.